Hey Geometry, let's look through lesson 10. We're still working on perimeter and area in the Cartesian plane, but today we're doing polygons, not just triangles. Okay, we're still going to use the shoelace method. We could also use decomposition. I'm not going to do each problem twice, so if you really prefer decomposition, that works for me. If you would prefer the shoelace formula, that works for me too. I'm going to do the opening exercise with both of them, but after that, I'm just going to go for one. So here's the opening exercise. Find the area of the triangle given. Compare your answer and method to your neighbors and discuss. Well, we're not going to compare our answer to our neighbors, but you can compare your answer to me. So first, let's try the decomposition method. That means I'm going to draw a rectangle around my triangle, and then subtract the triangles from it, right? If that makes sense. So if I look at if I look at the rectangle, my length is 1, 2, 3, 4, 5, 6 times 1, 2, 3 is 18. Then I'm going to subtract out the areas of each triangle. So the area of triangle 1 is 1/2, base is 1, 2, 3, 4, 5, height is 3. So that gives me 15, half of that is 7.5. Area of triangle 2 is 1/2, base is 1, height is 2. Got 1. And then the area of triangle 3. The base is 1 and the height is 6. So that area is, 3. So now I take the area of the rectangle and subtract out each triangle. And that gives me 6.5 square units. Okay, let's try the shoelace method. So my coordinates are A, -3, 2, B, 2, -1, and C, 3, 1. So if I start here and go around counterclockwise, we'll have the area equals 1/2 -3 times -1, -3 times -1, plus 2 times 1. I'm showing you up here, 2 times 1, plus, making sure I don't make any mistakes, 3 times 2. So those are all of our, that's our coordinates. Now we have to do the minus. I know this is tedious, but once we get the hang of it, it's actually super easy. Okay, so now we're going to do the minuses. Minus 2 times 2. 2 times 2. Remember, we do y then x. Minus -1 times 3. We did 2 times 2, now -1 times 3. Now minus 1 times -3. 1 times -3. All right, let's do that math. I have 1/2 times +3 plus 2 plus 6 minus 4 plus 3 plus 3. So that's 1/2 times 5, 11, 10, 9, 8, 7, 8, 9, 10, 11, 12, 13. Equals 6.5. We did it. Yay! Cool. Alrighty, let's move on. It's bad when our warm-up takes 4.5 minutes. All right. So if you remember last lesson, when we first talked about the shoelace formula, we talked about would it work with any quadrilateral? And we said yes, it would, but we didn't actually try it. That's what we're doing this lesson. Because what you see here with this quadrilateral is actually, like I have two triangles, right? So the shoelace formula is going to work with either. All you have to do is make sure you pick one point to start with and then go in a counterclockwise fashion. You just have 4 sets of points to work with instead of 3. So it does work, and we're going to work through that right now and prove how it works. So if you go along, you'll see it's going to work. All right, let's try it. Okay, this example is going to take a bit of time, but we got it. Okay, so first of all, identify the vertices. I identified them over there. See below the picture. Find the perimeter using the distance formula. So this would take a little bit of work, but it's all right. If I look at AB, if I just look at that right here, I've got the Pythagorean theorem, which is the distance formula. Pythagorean theorem, let's see, the distance formula is developed from the Pythagorean theorem. So 2 squared plus 2 squared, I'll calculate that in a minute. BC, if I go down here, 3 and 3. And then CD, 2 and 2. And then AD, I have 3 and 3 again. All right, hold on a second. All right, there is your perimeter. All right, now find the area using the area formula. As far as what area formula we would use, I've got right angles here. If we look, I guess I could try to erase that. Nope, I'm not going to be able to. Hold on. I tried to erase the markings that I did in this drawing, but I can't. We know this is a right angle. These are all +1, these are all -1. My slopes are positive and -1, so that's a right angle. So length times width gives me square root of 18 times the square root of 8, which equals, goodness, 18 times 8, no idea. Square root of 144, which is a perfect square, which is awesome. 12 units squared is my area. All right, so that was using regular methods. Let's go ahead and work with the shoelace formula. All right, list the vertices starting with A and moving counterclockwise. I did that here, just like I said in the past slide. Now we're going to verify the area using the shoelace formula. Okay, so what we're going to do here is the shoelace formula, remember? And then we'll come back and go that way. So we have plus and minus. Let's see if it works. So 1/2, we'll do the pluses first. 1 times 1 plus 4 times 3 plus 6 times 6 plus 4 times 3. Let me show you where I got all those. 1 times 1 is right here. 1 times 1, 4 times 3, 6 times 6, and then 4 times 3. Now let's subtract. So minus, now we're doing the reds. 4 times 4, 1 times 6, 3 times 3, and 1 times 6. Well, let me show you where I got those. 4 times 4, 1 times 6, 3 times 3, and then 1 times 6. Okay, let's check our work. This gives me 1/2 times 24, which does in fact equal 12. Okay, it really helped to write everything out like this. The last lesson, lesson 9, I tried to just follow the pattern going around the drawing. That's a little too difficult. So writing it out and making the shoelaces, you know, where everything crosses like shoelaces do, was much, much easier. Very cool. So let's try it again. Calculate the area and perimeter of the given quadrilateral using the shoelace formula. Okay. I'm going to list these starting with, let's start here and go counterclockwise. Over 6 up 2, 5, 4, 2, 5. So first we'll go this way, and then we'll go that way, the plus and the minus. So I have 1/2, 2 plus 24 plus 25 plus 2 minus, I'm following the blue, 6 minus 10 minus 8 minus 5. Let's check our math. This gives me 1/2 times 24, which again is 12. Cool, that is our area. Perimeter, let's just go through it. Let's see. AD is going to be, I'm just doing Pythagorean theorem. AD squared is 1 squared plus 1, 2, 3, 4. AB, let's see. I have 1, 1, 2, 3, 4, 5. 1 squared plus 5 squared. BC, 1, 2, 1. And then CD, 1, 1, 2, 3. Okay, let me calculate this really quick. So the perimeter is approximately 14.6 units, where the area 12 units squared. That's really fun. I like the shoelace formula. All right, break up the Pentagon to find the area using Green's theorem. Compare your method with a partner. If you guys are wondering what in the world is the Green's theorem, do not fear. The shoelace formula can also be called Green's theorem. Green's theorem is a high school geometry version of the exact same theorem that students learn in Calculus 3. Hey, you guys learn in Calculus 3. That's great. Students only need to know that the shoelace formula can also be referred to as Green's theorem. Cool? So let's break this into a trapezoid and a triangle, okay? So we have 2 pieces. Let's do the triangle, it's figure 1, and the trapezoid is figure 2. So for the triangle, let me list out the ordered pair. So my addition will be red, and my subtraction will be blue. And we're just going to do these 2 figures and sum what our answers are, just add them up. So I'll talk through it. You can fast forward if you've got it. x1, y2. Let's make that legible. x1, y2 plus x2, y3 plus x3, y1. Do not close your parentheses. Minus the blue. y1, x2 minus y2, x3 minus, let's see, y2, x3, y3, x1. And now let's do the trapezoid. So we're going to add that area. x1, y3, x3, y4, x4, y5, and last but not least, x5, y1. Now let's subtract the blues. y1, x3, y3, x4, y4, x5, and last but not least, y5, x1. So that's it. We don't necessarily need to simplify all of that, but I am going to put some numbers to it. And if you could also do that, let's see if we can get our answer. So I did all the variables. I'm going to push pause and put ordered pairs to those variables and get an answer. All right, those are all the numbers I got. And if you do all of that addition and subtraction, you get a total area of 20.5 units squared. Cool. If you don't get that, please let me know, and we will figure out what went wrong. Another one. Okay, I think I have, yep, 4, 5, and 6. Okay, so be patient. Find the perimeter of the area with a quadrilateral. I'm going to go ahead and list them out in the right order. I'm going to start with, I don't know, A, and work in a counterclockwise way. I'll be right back. Okay, so I get 1/2 -3 times -4 plus -4 times -3 plus 2 times 6 minus, oh no, I forgot one, plus 4 times 4. Then minus the blues. 4 times -4 is -16 minus -4 times 2 is -8 minus -3 times 4 is -12 minus -3 times 6 is -18. Well, that's sort of messy. Let's get rid of all those. All right, I'm going to add all these together. So I got 53 square units. Awesome, 2 more. And really, if you've got this, you don't have to keep going with me, right? Let's see, Pentagon again. All right, I'm going for it. I'm not splitting it up into 2. Let's see, where do I want to start? Let's start there and go around. So I'm going to list these in the correct order. -2, 4, C, -1, -2, B, 4, -3, A, 5, 8, and E, 2, 6. So we're going to add the red and subtract the blue. Okay, I'm going to do this on my own. You guys work on your own. All right, there we go. I hope you can see my work. I tried to show all little bits and pieces. Last one. Cool. 6 points. All right, list your points and go ahead and try it. Okay, I'll show all my work, but I'm going to push pause. I'm going to go black is addition and blue is subtraction. Okay, now I'm going to push pause again. I'll be right back with the answer. All right, there is your area. I'm going to work through the perimeter, and I'm just going to draw on the drawing, just using the Pythagorean theorem of what each side length is. That was awesome. Good English. You can go ahead and check yourself. I'm just going to go like here, right here, we have the square root of 5, 3, square root of 5. I guess I'll keep going. Square root of 5, 3, and the square root of 5. So if I add all of that for perimeter, I have 3 plus 3 is 6, plus 4 square roots of 5, because I've got 4 of them. That gives me 6 plus 4 root 5, about 14.9 units. Awesome. That's it for today. Good work.